Welcome. After we talk about the sigma and sigma sum, and I hope you take out some time to practice it to get familiar yourself with the concept. Again, link of the textbook, a free-ish textbook is in the description, and I also put out the link to each of the chapters that I'm talking. All right, so I hope you do have a chance for you to practice this on the sigma and sigma sum, and now let's jump to the Riemann sum. Um, Before we talk directly into Riemann sum, let's make an introduction and why we need a Riemann sum. All right, so let's imagine I have a very good object. It looks like this. It have a shaping like this. All right, let's make it even more curvier. All right, and luckily at my base here, is like it's like a rectangle at the base. This one is a straight line, so everything is a straight line except for the top. Okay, and so what I want is I want to measure the area of this. So I want to know what the area is equal to. Right, so shouldn't write A, but write the whole word area. What does this area equal to? And of course, if we think about Euclidean geometry, so which are like circles, rectangles, squares, triangles, and all the Euclidean geometries, shapes, we can't think of anything that we can't think of any formula of the area that help us to make sense of this curve, right? This not curve, but like this curvy object, right? And so that is when Riemann sums come in. Okay, so now let's pretending I'm going to bring up the same problem like this, but then uh the Riemann sum saying, well, what if I put this whole thing here like this onto the x and y axis? All right, so this is x-axis. Sorry, this is the y-axis. The below here is the x-axis. So it's not straight. My apologies. So I try to match my lines as much as I can. All right. So and bring out my interval. So this is of course 0, right? And this is some interval. Let's call it a. All right. So interval between 0 and a. What I want is to measure the area under the curve. So I want to measure this area, this part here. And so what are my ways of doing this? Now, as I just said before, we know the formula for a rectangle, right? It's base times, sorry, not base time height, but in this case, like look like base time height, but in general, we learn is width times the length, right? And so what I want to do is I want to define, let's just start to define this curvy thing into a much smaller rectangle, okay? A lot smaller rectangle. All right, and then gonna draw a rectangle to them. So depending on which side of I'm measuring, so really depending on how am I, so my bad in drawing, but again, so based on based on this, I can, just imagine all the width of this rectangle are equal because of my bad of drawing. Again, so I drew 1, 2, 3, 4, 5. I divide the curve into 5 rectangles. And what I want to do is I know the height of each. So right, I know I can tell the height of each of them. If you don't know how, I'll tell you later on about how to find height. But we know the height, we know the width, we can find the area of the rectangle. And for like this 5 rectangle, and I can estimate the area for the curve for the area under the curve. So meaning the whole area of this curvy box or whatever that is. Now, but we have to understand one more thing is that we cause some errors too. So this is called a left rectangle measurement because everything is based on the left side. So I draw everything, the rectangle is based on the left side. right? And so it looks like I left this out, right? It looks like I left those out. These can be causing me errors in my measurement, all right? Now, if I want to reducing that and using the same, the same left side, the left side height of the rectangle, what I have to do is I have to divide more rectangles. So imagine I'm not going to do this, right? And so imagine next time we should draw a better line. So instead of drawing 5 like the previous one, let's draw more rectangles out. So let's draw more. So again, the width are the same because of my drawing. Not doing a good job there. Oh my goodness, this one. So draw more, and more. Right. So again, still estimate from the left. And you can see that like this, so straight like this, straight. All right, now, right. So now you can see that I have more rectangle, but the errors, unlike the previous one, the errors you remember is kind of big, but these errors is smaller and smaller, right? So how many rectangle am I having in here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rectangles. So double the rectangles compared to the first one. So if I have more rectangles, my estimation of the area under the curve is more precise. All right. And so this is the idea of the Riemann sum. All right. And of course, I forgot to mention this. This whole curve right here is f of x. So it's a kind of a function of f of x. Let's say imagine we are like in a best case scenario where we know the function of this um, and we can draw out we can write out the function for the top hat curvy point here in the best case scenario in the ideal world. Of course, now this is the idea of Riemann sum. Okay, so area under a curve, and so that is how we. Oh, by the way, that is how we're gonna find the height of it. And so this I demonstrating right here. Oopsie, I draw it. I cannot undo it, so I'm gonna have to draw a new graph. So again, so this is the idea of a Riemann sum, which is I define if I want to estimate the area under the curve, and the curve doesn't appear to look like Euclidean geometry. What I have to do is, again, I have to divide the curve into more rectangle, as many rectangles as I can. And of course, the more, the better. The area got reduced, and I can estimate the area under the curve. All right, so let's grasp the idea of what is the Riemann sum. So what are the left side and the right side of the Riemann sum, okay? And so the left side of the Riemann sum, so let me draw the curve again. So another curve, let's say, because I cannot draw the same curve. So let's just imagine that this curve follows the function f of x, right? And so what I'm going to do in here is going to divide this into, so I'm going to estimate the curve, the area under the curve in the interval 0 to a. Now I want to divide the curve into more areas, right? Into more intervals. So what I want is I want to divide the curve, but this is the left side Riemann sum. So I'm going to draw this one. This is the left side Riemann sum. Left side, okay? So Riemann sum. So please let me use RS as a notation standing for Riemann sum, right? And so what I'll do is I'm going to draw down here, and I'm going to divide them into small rectangles, right? And so this is the left side. I should draw the straight line instead of doing this. Not really a big deal, but then the left side of the Riemann sum, meaning I estimate the height from the left side of the length. All right, so the left side, the length here, I draw a line to meet the right side of the length. Okay, So this is the left side of the rectangle, and draw another line. This is the left side and draw another line. This is the left side and draw another line. This is the left side and draw another line. This one's the left side, draw another line. This one left side, draw another line. Done. Now, what you may notice is that the left side of the Riemann sum tends to underestimating the area under the curve. All right, and so this is the right side of the Riemann sum, the right side here. Now, if I draw the curve again, so maybe a different curve. All right, so this is f of x, a function of f of x, and I'm estimating the area under the curve. So this is 0, and let's estimate this one is in A, okay? And so I want to estimate the area under the curve, so I'm going to divide it into smaller rectangles. All right. So now this is the right side of the Riemann sum. So what is the right side of the Riemann sum? So let's draw the curve like this, right? So this is my first one. This is my second one. Third one. Sorry, right side, not the left side. So erasing this one here, doing this one. All right. So this one, and so this one. Oopsie. Oh, the whole curve is gone. Can I redraw this one again? All right, let's just imagine. Ah, man, matching every. Oh my God, it's hard to redraw everything again by hand. Not like this though. This part here should be like this. Let's imagine it's something like that. Okay, and well, this with that like this one won't be that big. So it's gonna be this one over here, and the remaining like this. All right. So what you will see that on the right side, the Riemann sum, they tend to overestimate the area under the curve. All right. So this is the right side of the Riemann sum. Okay. And this is the left side of the Riemann sum. So you can see that I left out some blank right here, right? These are underestimating the area. So this I can estimate even further from the curve. These are overestimating the area under the curve. All right, so let's do a couple of exercises so get us to familiar ourselves with the idea of Riemann sum, like what's the left side, what's the right side, okay? And of course, oh, by the way, so yeah, for this one, right, what is the interval? What's the width of each of the rectangle? For this one, well, we're counting 1, 2, 3, 4, 5, 6, 7, right? And so each of them has to be like 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7 is A, right? So I'm talking A, and so I'm assuming part is A is equal to 1. And of course, if A is equal to 2, that'll be a total different story. And of course, I will talk about that in the next one in the following problem. But for now, let's assume that A is A, and I don't care any other things. Okay, if it's a 2, 3, then we will talk about that later on. All right. So again, you know the idea of how to define each of the intervals. So let's just walk through one example. Okay, so let's say we have one. We want to do the left side Riemann sum, and we want to estimate the function. So find the area. So we're going to find the area under the curve of x squared, right? And from the interval, sorry, from the interval 0 to 1. All right, so how are we going to do this? So first, let's draw out a curve of f is equal to x squared. We know for sure that this one looks like a parabola. A parabola. Oh my God. Parabola. Man, my mom is, I don't know what happened with me now. Parabola. Parabola, but oh, never mind. All right, so now parabolic curve. All right, so now we are not. Oh, of course we're gonna divide into four subinterval. All right, so what I want to do is we're going to draw a better parabola curve. All right, now this is from 0, right? And imagine this is 1, okay? I'm not sure if it's 1. And of course, we're going to draw a rectangle through them. And of course, we divide into four small subinterval, meaning well, we divide into four subintervals. So this will be 1, 2, 3, and 4 down there. And so I'll make 1, 2, 3, and 4 rectangles. Okay, but we are doing a left side Riemann sum. And so we're gonna do the left side of the Riemann sum. So we're gonna base on the length the length, yeah, the length on the left side of the rectangles. Now notice that since it's 0 is nothing there, right? So it's 0 at when f of x, when f of 0, it means 0 square, it means nothing. So 0 squared is equal to 0, nothing there. So that's the reason why I love to do left side Riemann sum. So that's why I don't need to care about the 0. So got one of them got eliminated. So let's draw this one like a rectangle here. All right. So how going to calculate this? So we're going to divide this into 4 rectangles, right? And so this one will be 1/4, 2/4, 3/4, and 4/4 is equal to 1, right? So this one right here, this one right here is equal to 4/4. All right, cool. Now let's estimate, let's find the area under this curve. Now it's just simple math, okay? It's completely simple math. So we're saying we agree that each width of the rectangle, the width of each rectangle is equal to 1/4, right? And so we only want to find the height of this. Now the height is based on the function of f of x, right? So meaning, well, what I'm going to do is the height of, for example, the height of this one is f of 1/4, right? And following the height of the other one is f of 2/4. The other one is f of 3/4. So let's just write that down. So the area under this curve is actually the sum of everything. So the sum of f of 0 times the width is 1/4, right? Plus f of 1/4 times 1/4 plus f of 2/4 times 1/4 plus f of 3/4 times 1/4, right? And the rest is just computational math. So meaning so if I have to calculate this, when we know the 0 is out, so 0 squared is out, f of x is equal to x squared, right? And I mean, so that's why f of 0 is equal to 0 squared. So 0 times 1/4 is out, completely out. So I don't care about this guy at all. I only care about the remainder of the guy. So it'll be 1/4 squared times 1/4 plus 2/4 squared times 1/4 plus 3/4 squared times 1/4. Pretty cool. And now the remaining, just take your calculator. If you already solved that in your mind, you're way better than I do. So 1/4 squared times 1/4, right? Plus 2/4 squared times 1/4 plus 3/4 squared times 1/4. And the answer is 7/32. So 7/32. And that is the, I love to put this, but again, not that important, or because we already master math in here. I love to do it just to put in that way. Anyway, so yeah, so this is the left side of Riemann sum, by the way. And we want to do the right side Riemann sum, we kind of do the same, right? And so then we're doing the right side Riemann sum for the above problem. right? And so right side Riemann sum. So we're gonna draw the same graph, okay? And so this is name it, a parabola. I have a troubles for saying parabola, okay? Parabola, parabola. All right, so it's equal to one. So interval is from one, 0 to 1, right? And so and it's not really a good habit of drawing a straight line like this because it's not straight, but I want to draw so we can see clearly the triangles. And so we're gonna divide into 4 sub-interval. So 1, 2, 3, 4, right? And then there'll be like, 1, 2, 3, so we'll have 4 rectangles right here, and we're doing the right side. So we're gonna draw a rectangle based on the right side of the length. Gonna map it to, right? So right side right here, so right side right here, so right side right here. So I wanna bring this one up so it goes to 21875. So I want to prove my point that the right side tends to overestimate it, right? So let's see. So again, I don't know. Sometimes I want to bring out the colors and it doesn't bring it out. Sometimes I don't want, and all of a sudden the color brought out. All right, so the right side, the right side, the right side. Now the right side is equal to, or I forgot to say, each of them subinterval again is like 1/4, 2/4, and 3/4 at same time as before, right? And 4/4 is equal to 1 at same time same as the before. And we're gonna do the Riemann sum for each of them. So we start with f1/4, right? Because we don't start with 0, 0 is the left side of the triangle. And we want to start with the right side of the rectangle. Okay. And so did I say triangle? If I say my triangle, my bad. So it should be a rectangle. So again, f of 1/4 times 1/4, f of 2/4 times 1/4 plus f of 3/4 times 1/4 plus f of 4/4 times 1/4. All right, I got lazy to simplifying the 2/4 and 4/4, but you can simplify if you want. So 1/4, sorry, not plus, but times 1/4 plus 2/4 square times, all right, the reason I'm doing I know this because this one is f of x is equal to x squared, right? And so this is the reason why I'm doing that, times 1/4 plus 4/4 in 1 square times 1/4. So on the calculator, I'm gonna do it out, times 1/4. All right, we got like 15/32, and I think that's simply, I thought it gonna be some random numbers, but on the fraction, we already can see that it is much bigger than the previous one, right? So this is the answer. The previous one we got like 0.21875. This one is 0.46875. Tend to overestimating things for the right side. The left side tends to underestimating things. All right. So now we kind of understand the Riemann sum and the idea for the Riemann sum. Now but then this is kind of we divide into like the number of rectangles we can count. But then you remember I say, well, if I want, for example, if I draw the curve right here, the curve of this, right? Let's draw it again, and I want to estimate from 0 to sorry, right, let's just bring it out from A to B. All right, I want to estimate the area under the curve. Now I did say one thing that the more rectangles I divided into, the more precise of the area under the curve would be, correct? And so that means my I have to keep dividing into much more rectangles, and so that I can reach out to the a most precise and accurate area under the curve. So that means if you keep imagining, you'll keep dividing more and more and more and more until I can count. That means n is approaching to infinity, right? It has to infinity rectangle so that I can do the measure of the area under each of the rectangles until I can count. Um, sorry, if I bring it to like infinity, the more rectangles I have, the more precise area on the curve would be. Okay, so in this scenario, what I'm going to do is we want is to find a general formula for each of them. And so this is going to be a little bit challenging, of course. But again, it all follows the same idea, right? It follows the same. So let me walk you through onto this one. So I want to, let's say I want to estimate, so I want to write, want to find the area. Oh, forgot to write this one. So again, completely forgot to write this one. The reason why I'm drawing this graph out, I have to show you guys this. All right. Now, if I want to bring everything, all right, so I'm going this, dividing this, dividing this, dividing this into a lot of rectangles. So again, so imagine I cannot count, even counting it. So like dividing a lot of rectangles. It's still countable, but imagine I divide until like the point where I cannot count it, and I got the most precise measurement of the area under the curve. The Riemann sum is then written as, sorry, not starting with, but the sum of, so again, I'm going to do this first. So we're gonna estimate on the x of x, so plus, right? For example, we start with y, sorry. So we start with the smaller intervals. The smallest is a, right? We divide into n rectangles. So the n is like the last number of rectangles we are divided into. And so the Riemann sum is then written as, well, a plus 0 over n is just 0. It's just a. So that means I'm measuring the left side of the Riemann sum. So let's just write the left side Riemann sum. So let's just do the left side first, and then we can do the right side later on. So we got the height, the left side, times the length of it is 1 over n, right? Because it's like we divide into n rectangles. In previous, you can see we divide into 4 is 1 over 4 with the width of each rectangle is 1 over 4. But now we're dividing into n rectangles, so the width is 1 over n rectangle, right? And so plus, a plus, again, the reason why is a plus, because I want to continue from a here, right? I'm not starting from 0 at all. And so it's the reason why I'm starting from a and then continue plus each of the interval, okay? And so times this, and then dot until f of a. Now, we're talking about left side Riemann sum, and so I'm not going to take the case of n over n. I'm going to take a case of n minus 1 over n times 1 over n. All right, and so I can factor everything out. So factor everything out, then I got f of a, I'm going to write a big bracket here, so calculating, not factor everything out, but I can factor until I can bring this one out, right? So this is my goal here. I want to bring this one out. So plus until, because this is a left side Riemann sum. That's why I only evaluate until n minus 1 over n, right? And then I times this one. Now, what is going on over here is that, well, I'm gonna write a sigma sum for each of them. And of course, if you haven't watched the video of sigma sum and you don't know the idea of sigma sum, please come back to watch it. I'm gonna put a link down the video. Of course, gonna group everything right here and write into a sigma sum to make it look clean, okay? So my everything is start from I is equal to 0, right? So I'm writing sigma notation. And my last one is n is equal to minus 1. And of course, what I'm adding all the f's together. So fa plus I over n, right? Times 1 over n. All right. Now this one, this right here, f, we then would written of what the function is all about, right? So if, for example, if we say f of x is equal to x squared, then the whole thing here will be, well, it will be this one, right? So the whole thing here, square plus 1 over I, right? And so it depends on what the function I'm talking about. From here, I think I can stop here because the remaining is all dependent on the function, what we are talking about. And of course, I did say one thing that if f is as again f is more the more rectangles, the more precise area under the curve. That means the number of rectangles has to approach infinity. So it has to be a lot of rectangles to measure the right area under the curve. And so that's the reason why we put out the limits as n approach infinity. Okay. And so this is the formula for the for the left side of the Riemann sum. Now, if you want me to do the right side, I can do it. So I'm gonna write out the right side of the Riemann sum. Of course, I'm gonna following this. Of course, I'm gonna following this curve. So trying to, sorry, imagine, sorry, just erasing that one. So again, so let's just say, well, how can I estimate the right side of the curve? So instead of starting with 0, so 0 is the left side length of the rectangles. I'm starting with the right side length of the rectangle. So I'm not starting with 0 over n, but instead I'm starting with a plus f of a plus 1 over n, right? So this is the right side of the rectangle, right? I should write everything properly so we can see it properly. Plus 1 over n times the width, and of course we keep writing, so plus 2 over n times 1 over n, right? Dot until I got like f of a plus n over n, where n over n is equal to 1 times 1 over n. All right, so we can factor out 1 over n. We can factor them out exactly from the previous one. So 1 over, I'm gonna write a big one. Let's write a big bracket. Plus 1 over n plus f of a plus 2 over n, right? And plus dot f of a plus n over n, so meaning 1, and times 1 over n, right? Now I want to simplify this whole thing here in terms of sigma. So my sigma, my index start with 1 and with n. So I'm writing a sigma notation of f of a plus I over n, exactly the same as before, and times 1 over n. Now, of course, I'm going to write the limit and to infinity to show that, well, again, the idea is the more rectangle, the more precise of the area. Of course, if I have keep adding rectangles, mean I have to add it to the infinity to get the right area under the curve. All right. So this is the idea of the Riemann sum. Okay, this is the serious version of the Riemann sum. Now, you want me to walk through some examples? I can do that. Let's say I'm estimating this. So let's try to estimate. So not even estimate. Now we're gonna find the expression. Find the expression of sorry, not of, but for the function 1 over x from the interval from 1 to 2. All right. So how can we gonna do with this? Find the expression for this one. So if you would like to draw the curve, you feel free to do it. I'm not against it. I'm just a little bit lazy right now, so I'm not going to draw the curve out. Probably just draw the curve and see. And let's just know more about this one. This one I'm suddenly changed. Crazy. I have to fix this one again. My bad. Um, I don't know why. I don't know what happened with this. It keeps jumping. The page is frozen. I'm opening a chest plate over here, and it's keep like I don't know. It kept frozen, and then it kept jumping, and then frozen, jumping. Some move like got stuck and things like that. I don't know. Sometimes I bring out the chest here just like for entertainment when I'm studying. It's not even entertaining that way at all. My bad. Let's just draw on the curve. Oh my goodness. Let's draw out the curve of here until here. All right. So what do we want estimating? We're on estimating between these two interval 1 and 2. Probably I have to, probably I don't care about this part at all. Only care about positive since we only care about the interval from 1 to 2. And I can draw bigger. And so, probably we can see this clearly. And of course, we don't estimate everything in the left. Sorry, if we're not, we can't see everything in the left side of Riemann sum. Let's estimate in this one is the left side of Riemann sum. I love left sides. Why? But I can later on do the right side later on. Don't worry. I love the left side because we can kind of like not ignoring one of them. But the same with the right side. But we cannot like sometimes when we have the expression of 0 and we can ignore the 0, so we don't need to calculate anything at all. Lazy rule. But again, I can do the right side later on, so not that big a deal. So let's divide this. I don't know. I don't know what's going on. Someone messaging me and I have no idea what this is, but never mind. So let's divide this into like rectangles, and of course we're measuring on the left side. So this right, not this one, not this one. My bad. We're gonna estimate everything from the left side. So here, right here, here. Now, of course, again, I'm saying we're drawing the graph. It's not that big of a deal. I'm not drawing. You're not even big of a deal. And so how gonna find the expression for this one? And so what I'm gonna do is we're gonna write the function out. So again, so it's one plus 1 over, so first with 0 over n, my bad, right, times 1 over n, right? Because again, we don't know what n is. We just in our mind, n is infinity, right? So I don't know what n is. Someone called me also. I'll answer the phone later on. Plus again, so 1 plus 1 over n times 1 over n plus plus 1 plus n over n, right, times 1 over n. All right, so now this is the interval between 1 and 2. And so there's nothing much to consider in this case at all. Yeah, so continue. So this one is so the whole thing here, I can do the same, exactly the same, factoring things out. Oh, so I should write this one, f of x is equal to 1 over x. My bad. So this one, f of x is equal to 1 of x. All right. And so continue. And so we're exactly doing exactly the previous one I showed you. So f of 1 plus 0 over n, right, plus f of 1 plus 1 over n, right, plus plus of f 1 plus n over n times 1 over n, right? So everything put in a bracket. And now I'm gonna, oh my God, not n over n. Why did I say over n over n? It should be n minus 1 over n. All right. So I'm gonna put everything in a bracket. And so now I'm going to write the Riemann expression in here. So am I evaluating to the last one, n minus 1? The first one, the first index is I is equal to 0 of f of a plus I over n, right, times 1 over n. Cool. And of course, you know, I did say that the more n, the better. So n approach infinity. All right. Now, as limit n approach infinity. All right. Now we're gonna do the well, we're gonna do this. I'm gonna change this expression. So n minus 1. So because f of x is equal to 1 over x, right? And so that would mean this whole thing here, meaning 1 plus 1 over 1 plus I over n, and then times 1 over n. So pause the video if you don't get it, and think it through. Okay, and so limit of n approach infinity. Okay, so n minus 1. I can start to simplify everything in here. So meaning we'll just 1 or plus, so it's like n plus I over n times 1 over n, right? So okay, I can simplify from here. So it's equal to n times n plus 1, right? And then I can cancel the n out. And so that whole thing here means equal to 1 plus 1 over n plus I. And this is the expression. So it didn't tell me to calculate the area under the curve using Riemann sum. Instead, it asked me to find the expression. This is the expression for it. And this is how we're going to find the Riemann sum for it. Of course, later on, I'm going to tell you how we can find it to the converting back to the definite integral expression. I don't want to talk about too much about definite integral. You know, it will be on the next video, as you can guess. But for now, not necessarily, not really my right. So if you wanna do the right side, we can do the same thing. All right. Instead, we start with row a plus a plus oh, sorry, did I say a plus? Oh, let's say 1 plus. Lucky me. If I say a plus, I'm punch myself. A plus 1 over n times 1 over n plus a plus 2 over n times 1 over n plus dot 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 plus a plus so n over n, right? Times 1 over n, right? I'm gonna factor things out, so I'm gonna factor this out. F of a plus 1 over n plus a plus 2 over n, right? Plus dot 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 f of a plus n over n. So this I've got factor out, so this the width is 1 over n, right? And so this one I can rewrite as the Riemann sum. So from n I is equal to 1, right? And the expression is f of a plus I over n times 1 over n. Of course, I have to add a limit n to infinity, right? So the limit of n to infinity, and from n, the sigma index start with 1, and the whole thing. Whoa, I just say a again. Wow. I just say I'll punch myself, and you will say a, and then I from here I say a. Punch myself. Oh, God. All right. A one, one. All right, 1. All right, so plus I over n times 1 over n. So I can reduce everything, exactly the same expression. So it'll be like 1 over n plus I. Or the same thing as the previous one. It's just the sigma sum got different. Same as this one. The sigma sum is different. They are the same thing. All right. And of course, you can do a lot of different tricks on here. I can see a lot of different tricks you can apply. Actually, you can do, hold on. Actually, you can do different, lots of different tricks, right? All right, so if I missed anything, I feel like I'm missing something in here. But if I miss everything, just post a comment on there. I'll try my best to um correcting it. All right, and so yeah, so it just asked me to find the expression. So this is what I want to do. I'm not all going to evaluating that. Of course, if I want to reevaluating this, just treating this one as the limit case, right? And so um, let's see. So if I want to reevaluate this, right? So what I want to do is I'm going to treating this one as a limit case. We're gonna find the limit of it, and of course there'll be a lot of different words on there. But let's not complicate things. Of course I'll bring out another one to find the limit, better one. For this one, let's keep it like this. Let's keep it like this. All right. So to sum up, and of course the video should be end right here. So if I find the expression of Riemann sum, it can be 0, can be 1, and just say start at 1, right? So if I write out the expressions, this is the width, okay? Now, if it's 1 over n, meaning the interval is different. So if it's 1 over n times n, then the interval difference is only 1 unit. So meaning a 0 to 1, right? 1 or 1 to 2, right? So if I say like 10 or 12, sorry, 20 to 11, something like that. Okay, it's the interval is only 1 unit. If in case it's saying, well, it's 2 over n, right? That means, oh, so this is 1 over n. Let's keep it that way, right? So if it's 2 over n, that means the difference of the intervals are 2 units. So it's 0, 2, right? Or like, sorry, 2, 4, let's say. And it's 10, 12, right? The different, the interval are true, always 2 units, okay? But the most important thing is what is the starting point, right? So R, right? R. So the most important thing is what is the starting point? Now, the A in here, this A here usually tell me where to start. Now, remember when I do this addition, when I do the Riemann sum, let's not draw it again. But again, remember when I do the Riemann sum on this question, I tend to use 1 plus 1 plus 1 plus. Why 1 plus? Because I'm starting at 1. Now, at the same point, if I'm saying, well, A plus, this thing here, this A plus here is mean, so A is actually equal to the starting point of the interval. So meaning usually it's like it's the starting point of the interval. So so in this expression, so if I'm saying, well, A is the starting point, right? So the interval has to be A plus 1, right? Because we are evaluating 1 over n times n is equal to 1, so difference only 1 unit. And so this is the evaluating from A to A plus 1. All right. And of course, this is how we're gonna find it. And of course, I have a question as you further of like the what is it? The Riemann sum into definite integral. If ever you first encounter that one. So again, we know for this one, we know the starting and the ending point of the interval. So we're gonna write the ending point at the top, the starting at the below, exactly as the Riemann sum. And of course, I'm going to into definite integral into the next video. But for this video, I'm going to call it a symbol, okay? So f of x, right? Because the whole point here, this one is a, and the remaining here is x, all right? Because again, remember we divide a, sorry, we're dividing 1 plus, no, sorry, 1 plus 0, 1 over n, right? 1 plus 1 over n, 1 plus n minus 1 over n. these are the x-axis. These are f of x, right? And so, of course, we're going to write this one is f of x and then dx. The reason why this one doesn't take in the note is because it's just it divide into the width. The integral in the definite integral is more about integrating the function. And so I will talk about this later on in the next video of definite integral. But again, this is how we're going to rewrite the Riemann sum into definite integral. This only for anyone who got asked into to do the conversion from the Riemann sum into definite integral. We can walk through an example for this one. So this one is something I have done previously, which is a very cool question, and I like it a lot. And so I is equal to 1. So I squared plus 3in plus I just switch my monitors back to my my Word document that I prepared some problems so I can walk through on this tablet. So sorry, not this one. It's I squared I over n over sorry, n squared times 1 over n. All right, so for this problem, it's nice enough to let me know that is 1 over n is actually the width of the rectangle. Nice enough to let me know in that way. Of course, in real life, you know, in real life, in real life, in university life, they will write it there right there, let us to figure it out by ourselves. But from here, it's nice enough to let me know that, well, this is the width of the rectangle. And so how I'm going to deal with the other one. So again, let's following this one. So now I know that one is the width. Is again, what's the difference between each of the integral? So each of them is only different by 1 unit. So the interval different only by 1 unit. So now we're going to look at for the expression right here. So can I convert this expression into the definite integral, or we can can we find it into the converting this into the expression in words? Let's do it. I can write in words, or I can write the indefinite integral depending on what your need is. I can do both anyway. So I'm going to simplify this expression. Okay, so I'm going to doing this, simplifying things. Not I squared, I believe it's n squared. This one is n squared sine I over n over n squared times 1 over n, right? So everything here times 1 over n, right? And then I'm first simplifying this, right? And this one is 1 I over n everything squared plus 3i over n plus 9 sine I over n, right? So I can write the 3 here so we can see it nicer and better, times 1 over n, right? A limit n to infinity and I is equal to 1. Now we can write this back to the, no, okay, I think I feel like to stop entering here. Now can I write can I converting this into definite integral? Now I said earlier, right? So everything for the expression of this, a plus I over n, and of course I over n is x, right? And so do we have a here? So everything has a, but again, a is equal to what? A is equal to 0. Now I know for sure that this one is reevaluating at the interval from 0, and of course the difference only 1 unit is 0 to 1. And what my function is? My function is, so I'm going to be writing everything here in terms of x, right? So x squared plus 3x plus 9 sine x. And this is the expression. So you want to writing this in terms of definite integral, right? So they will be equal to definite integral. The bottom one is where the interval start at 0, ends at 1, right? And so rewriting the whole thing. So x squared plus 3x plus 9 sine x dx. And this is the expression for it. Now, if you want to write by word, is the expression. So this is in words. So the expression of the function f of x is equal to x squared plus 3x plus 9 sine x. Ouch. Now I don't have enough space, so f of x is equal to x squared plus 3x plus 9 sine x of the area under the function. Let's expand it with more word between between, but in the interval of function in the interval of 0 to 1. All right, makes sense. I think it's very easy, right? I feel like it's hard to be easy. So yeah, so you'll grab the idea of you understanding it. Feel free to skip this video. And the last one, I'm going to bring out why we have to learn sigma sum. Why we have to learn the notation of sigma sum, and you know what is going on right here, and can I actually measure the area under the curve using this the Riemann sum, the idea of Riemann sum. Okay, so I'm gonna do this. So I'm gonna start with this one. So I'm gonna work in this problem. So um I think by now we grab this. These are the two same expression, by the way. So let's not write too many words. Let's just start out reevaluating this. Reevaluate this one. So it start from 1, sorry, start from 0 to 1 of f of x, e to the power of x dx, in terms of sigma sum, in terms of Riemann sum. So how can I do this, right? Now this one is a very cool one. This side I took it from this one and the previous problem. The previous problem I take from x on the arc. The school the school that gave out this problem is the MIT University, so Massachusetts Institution of Technology. So this is where the problem come from. Okay, and so now first, all right, so first the idea is we have to find the area under the curve. The second idea is that we have to, well, the first idea is we have to rewrite this in terms of Riemann sum. The second idea is that we have to calculate the area under the curve. Okay, find the expression for this. Now, how are we gonna do this? Now, this is kind of a challenge for me because again, there's a second part I didn't finish, but hopefully we work through it. We can find how to do it, right? And so the first one, let's write everything here in terms of Riemann sum, right? So it really depends on what you want. I personally like the left side Riemann sum. You can like the right side. You can rewriting this in terms of the right side, but then my belief is that the area comes out to be equal the same. So if I rewrite the left hand, not the left hand, but left side of the Riemann sum. All right, so let's think in terms of e to the power of x, right? E to the power of x. So e to the power of x, right? And this is where e from, and then I think it should be going up like the exponential function, right? And so evaluating from 0, so from 0 to 1, this is right here. All right, so This is f of x is equal to e to the power of x. Let me know if I got wrong, because I don't care about the function at all. My main objective is my main, no, my bad. So this is one, this is one. I'm thinking about this is e. All right, my bad. So I was thinking about this one is equal to one. Anyway, my bad. So yeah, let's start with this. All right, so want to define this into a lot of rectangles, right? Until we cannot even count it. A lot rectangle until this one, the last one is n, and I'm going to revise this. I'm going to count. We're going to calculate this in the left side of the Riemann sum. All right. So of course, I can start by drawing, writing, well, um, f of, f of, first is like I zero, because zero plus, again, I can write zero plus, just exactly like the top there, but zero plus something is equal to itself. So I don't even bother to write this. The left side, the Riemann sum. So start with 0 over n, right? Times 1 over n plus f of 1 over n times 1 over n, right? Plus of f of n over, I'm sorry, n minus 1 over n times 1 over n. All right, so I'm going to factor this out. So I'm going to factor this out. So inside the left is 0 over n plus f of 1 over n plus plus f of n minus 1 over n. Ooh, my apologies, the video got too long, but for now, I think you can skip it if you know how to do it, right? And so I can write out this again in terms of Riemann sum. So I'm starting from 0, ends at n minus 1. So we're writing this one look pretty, n minus 1, starting from 0, and f of I over n, right? Times 1 over n. Of course, the whole thing, I'm reevaluating this in terms of um, limit x n you approach infinity. And of course, the whole expression here, right, is n minus 1 to I over n, right? The whole thing here is mean, so e to the power I over n, t to the power I over n, and everything over n. And this is the expression. So we found out the expression for it. All right. And so now our goal is to simplify this expression. Now, again, my warning is that you need to use the previous knowledge from the sigma and sigma sum, the second one, and the last problem that I'm talking about, and you will see why. And so anything that is irrelevant with the sigma, I can bring it out. So sigma only deal with the I expression. And so I can bring this one out first, right? I and minus 1, I is equal to, oh, sorry, so 1 minus n, 1 over n, can bring this one out, right? And so and minus 1, I is 0, evaluating this e to the power I over n. Now, you remember the first video, on the last video, I mentioned about if I revaluing this one, right? X to the power of k, right? That means, what that mean for x0 plus x1 plus x2, right? Plus 2x I power n minus 1. That means I only have to time what? 1 minus x and 1 0 xk, right? And so 1 minus x times onto each side of it, 1 plus 2 plus other plus x to the power n minus 1, right? And so then I can reevaluate this one because this time this one again is x to 0 plus x1 plus x power 2 plus to x power n minus 1, right? And this one is times 1, it's not 1, sorry, this is minus, right? X 1 because x times x0 is x1 plus x2 plus x3 plus dot 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 until xn. Ooh. I'm gonna ignore x3, put xn right here, right? Then I can cancel everything. This one out, this one out, this one out, this one out, x3 out, right? This one also out because just what I call it xn there. Then I got, sorry, I should write this one right here. Then I can say, well, the sigma I is equal to 0, x of k. Oh, did I say x of k? And then I say x of n. Oh, no. I should change this one is to x of I instead, because I'm starting with I, not k. I, I, I. All right. And so that would be equal to 1 minus x of n over x minus 1 minus x. Right? So this is the expression for this, right? The same thing happens. So if I have e to the power of I over n, all I have to do is change everything here to 1, not 1, but I over n, right? That means everything here is I over 0 over n plus e to the power of 1 over n, right? Plus dot 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 until e to the power of n minus 1 over n, right? So that means I'm subtracting what? I'm subtracting 1 to the power 1 minus e to the power of 1 over n, right? So then this thing is changing, and this whole thing is changing, right? So e to the power I over n here, e to the power I over n, oh sorry, not I over n, but 1 over n, and e to the power of 0 over n plus e to the power of 1 over n plus into e to the power n minus 1 over n, right? And can rewrite this one and the whole thing here to change too. So this one is e to the power of 0 over n plus 1, right? Um, what plus e to the power 1 over n plus dot into e to the power n minus 1 over n. And the other one here there is minus. So so minus for e over power of 1 over n, sorry, e to the power 1, right? E to the power 1. Hold on, what? So the b plus. Did I make? Did I happen to or some? All right, so I think I'm a little bit tired, so I just pause a little bit and drink some water, and now I'm fine. So let's go with it. So it will be so this one times this one, then I got like 1 over n here, right? E to the power 2 over n plus dot into e to the power n over n. So that means 1. All right, so now I can cancel everything out. Of course, this one out, like because the minus right here. So this one out, the other one out, the 2 out also. So what I have left is, e to the power of so the expression here is equal to 1 minus e and over 1 minus e over to the power of 1 over n. It's kind of a long way to solving this, but if you get used to it, it'll be much easier than doing this. All right. So yeah, so then I have the whole expression right here. Then I can substitute the whole expression of this one back to this one here. Okay, substitute into here. So that means I'm reevaluating the limit from n to infinity. 1 over n times the whole expression right here is 1 minus e over 1 minus e to the power of 1 over I n. All right. So then let's evaluate this one. So now let's evaluating the limit of this guy over here. And of course, the limits only take care of n. So whatever is not n, I can bring it all out. And so I can bring 1 minus e out since the limit doesn't care about the e at all. It only care about n, right? Anything that has n, so limit n to infinity, 1 over n times 1, oh, sorry, not 1 minus e anymore. So it'll be 1 over, so 1, oh, sorry, 1 minus e to the power 1 over n. All right, so feel free to pause the video and doing this. This actually to solving this require differential calculus knowledge, which is El Hospital rule. Not sure, El Hospital, El Hospital rule. Hospital. I want to go to hospital now. El Hospital rule. Okay, and so because if I approach if I let them into infinity, I'll have the case of, so if I of course 1 over infinity, right, times 1 to minus e to the power infinity, then I have the case of I cannot evaluate them at all, so it'd be infinity 1 over infinity, um sorry, 1 over infinity is equal to 0 right here, and e to the power infinity 1 minus e to the power infinity. I don't think I can reevaluate this one anymore. So the whole thing here is equal to 0. This is oh, no. Sorry, my bad, my bad, my bad, my bad. Well, 1 over infinity, okay, times, oh my god, what did I say? E to power infinity. 1 over infinity, right? So the whole thing here, so it'd be 0 times 1 over 1 minus 1. 1 minus 1 is, because again 1 over infinity is 0, and so 1 over 0. So we in case of 0 over 0, that's why we cannot evaluate this limit, and we can use the L hospital rule. Okay, and so because we reached the case of 0 over 0. My bad. I didn't. After saying that, I was like, it sounds something very wrong right there. And so what I'm gonna do with the El Hospital rule is that we're gonna differentiate them. So now what I'm gonna do is bring it into numerator, and this one is in denominator, and this is the this is where the El Hospital rule kick in, is that we can do the derivative on the numerator and the denominator. So I'm gonna and do, that's all right. Why didn't I write it again? And so I'm gonna do the derivative of the numerator, and then I'm gonna do the derivative on the denominator. All right, so 1 minus e, right? So 1 minus e, right? So again, so I'm gonna do the derivative, this whole thing here. So this whole thing here is negative 1 over n squared. The left, the bottom here, we do the derivative. We do the derivative. There'll be 1 over e times, sorry, negative e, and then I have to derivative of this one, right? Do derivative of this one. That means I got 1 over n, negative 1 over n squared. And so negative and negative cancel out, and so cancel out, and I got this one. All right, so again I can cancel this too. All right, so then I got 1 over minus e limit n to infinity, right? 1 over e to the power n minus, sorry, negative 1 to the power e power 1 over n. Now we actually can reevaluate this one, so that will equal 1 over e, or my 1 minus e, times, negative 1 over e to the power 1 over infinity. Well, 1 over infinity, as we discussed earlier, is equal to 0. All right, e to the power of 0, so 1 minus e times e to the power of 0 is 1. So we negative 1 times the whole expression here. That's equal to negative 1 plus e. And this is the area under the curve. Now it's a lot of steps. There's a lot of steps to reevaluate this area. This area right here. So These are the many of steps we have to go through. Now it's really, really pain in the ass. But again, try your best to work it out. Do more practices to converting the agreement. The most important thing, converting Riemann sum into either a sentence or the or this definite integral. Of course, in this video, I don't touch a lot in definite integral because we're not talking about yet the fundamental theorem of calculus. That's why we're not going to talk about definite integral a lot. And for sure, the next video will be on definite integral. And thank you so much for watching. I hope to see you in the next one. I also make a video timestamp on the video. If you want to come back to any other part, you can follow the timestamp there in the description if it's not showing on the video. Thank you so much for watching this. I hope to see you next one. Bye.